Why don't we look at a function that we are very comfortable with? How about f of x equals x squared, which looks like this right here. What would happen if you went f of, let's say, x minus, let's say, 3? So that would be x minus 3 squared. So we're taking the parent parabola, and we'd be moving it 3 spaces to the right. Yes, something like that here. It's the same shape, but it's been moved 3 spaces to the right. If you compare this with that, f of x is the original. F of x minus 3, you're taking the original function and you're moving it 3 spaces to the right. Now let's go back over here to this one. Let's suppose I go from like -2 to 2. And I consider, let's say, this area here. Well, I want to move these limits of integration over here so that the area here is the same as the area there. I want to draw something here so it's the same area as that one there. So it follows that if this guy is moved 3 spaces to the right, then you got to take these numbers here and also move them 3 spaces to the right. So if you add 3 and if you add 3, if I add 3 to -2, I get back 1. And if I add 3 to 2, I get back 5. So you see, what happens is, if you move a graph 3 spaces to the right, then you have to move the limits of integration also 3 spaces to the right, like this. This here, what's going on here is, this is from -2 to 2 of f of x. This is the same area as this. I mean, it's not a good picture, but it communicates the idea. So here, if this is going to be x minus 3 dx, then what should these guys be to get back 5? So these guys are equal because they represent the same area, although the locations of those areas are in different spots, but it's the same thing. Let's say you had integral, let's say like 4 to 13, I'm just making this up. Let's say h of x dx. And this is supposed to equal h of, let's say, x plus 7 dx. So my question to you is, what goes here, right? If this is supposed to equal that, then what should be these limits of integration? Well, let's see. How does this graph compare to this graph? This is the original. I don't know where it is, but that's the original. This one compared to that one, this one has been pulled 7 spaces to the left. You've dragged it, boom, 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 7 spaces to the left. So if you've moved everything 7 spaces to the left, you also have to move these guys 7 spaces to the left. So let's subtract 7 from here. Subtract 7 to get -3. Subtract 7 to get 6. So these here, they represent the same number. It's the area under this curve from here to here is the same as the area under this curve from there to there. What if you had to go not from here to there, but from here to here? That's the trickier part. So let's say that I have a function. Let's say I have like -7 to like 20. And this is going to be like q of, let's say, x minus 3 dx. So this is the one that's been moved. I want to know what the original would look like. This is the one that's given, and here you want to find the limits of integration. So ask yourself, what has to happen to this graph to make it to look like this? If you want this picture to look like that picture, then this picture has to be moved 3 spaces to the left, right? Because from here to here, this has been pulled 3 spaces to the right. So if you want this one to look like the original, you're going to have to move this guy 3 spaces to the left, which means subtract 3 from here and subtract 3 from there. So that's how these guys work. Whenever you shift this parentheses, this argument, you're going to be shifting these limits of integration.